In our last video, we explored a technology that could peek inside the human mind-reading AI. From its past to its possible future, we saw how unpredictable tomorrow's world can be. But there's another technology that could be even more powerful than AI. A machine that may reshape both our thoughts and our world: quantum computing. Movies have shown us quantum computers as glowing magical boxes that predict the future and hack every password in seconds. But in reality, they look more like golden chandeliers, hanging inside refrigerators colder than outer space. And yet, despite their humble looks, they're carrying us into a whole new era of computing. So the real question is, why do people call quantum computers the most powerful machines ever built? Today, we'll find out. In our last video, we explored a technology that could peek inside the human mind-reading AI. From its past to its possible future, we saw how unpredictable tomorrow's world can be. But there's another technology that could be even more powerful than AI. A machine that may reshape both our thoughts and our world: quantum computing. Movies have shown us quantum computers as glowing magical boxes that predict the future and hack every password in seconds. But in reality, they look more like golden chandeliers, hanging inside refrigerators colder than outer space. And yet, despite their humble looks, they're carrying us into a whole new era of computing. So the real question is, why do people call quantum computers the most powerful machines ever built? Today, we'll find out. 1. Science fiction illusion versus reality. Movies have taught us that quantum computers look like glowing boxes of magic. They predict the future, teleport humans, and hack every password in seconds. But step into a real lab, and the picture changes completely. Today's quantum computers look more like golden chandeliers, hanging inside refrigerators colder than outer space. Not exactly Hollywood, right? Yet, despite their humble looks, these machines are carrying humanity into an entirely new era of computing. But why do people hype quantum computers as the most powerful machines ever built? Let's find out. 2. Why people hype it so much. Quantum computing promises to do what no supercomputer can: simulate molecules for life-saving drugs, design better materials for batteries, optimize traffic for megacities, and even push artificial intelligence to the next level. It's not just hype for the sake of headlines. The math behind it proves that certain problems classical computers choke on, quantum machines can solve with elegance. To understand why, we need to go deep into the strange science behind it. And trust me, it's going to feel like stepping into a sci-fi novel. 3. The superposition mystery. In classical computing, a bit is simple: 0 or 1, off or on. But in quantum computing, qubits can be in a state called superposition. Think of a spinning coin. Until it lands, it's not heads or tails, it's both at once. That's what makes qubits so powerful. They don't just process one reality at a time, they explore many at once. And if superposition wasn't strange enough, wait till you meet its partner in crime: entanglement. 4. The magic of entanglement. Einstein called it spooky action at a distance. When two qubits are entangled, their states are linked instantly, no matter how far apart they are. Change one, and the other reacts immediately, across a lab, or across the planet. In 2020, China's NISQ satellite proved this by entangling particles over 1,200 kilometers apart. Imagine the possibilities for secure communication, unhackable networks, and even a future quantum internet. But let's not get carried away. How are qubits different from the everyday bits inside your laptop? 5. Qubits versus classical bits. A classical bit is a binary switch. It's either 0 or 1. A qubit is more like a wave, existing in a spectrum of possibilities. And when you link multiple qubits together, their combined states grow exponentially. That's why just 50 qubits can, in theory, outpace the most powerful classical supercomputer. So where do these strange properties actually give us an advantage? 6. Quantum advantage. Where it shines, quantum computers aren't faster at everything. They shine in specific problems classical machines simply cannot scale to handle. For example, simulating molecules in chemistry, optimizing massive supply chains, or breaking down certain cryptographic codes. Think about it. Simulating caffeine, just 95 electrons, is impossible for today's supercomputers. But a well-designed quantum computer could handle it. And this brings us to one of the most famous milestones in quantum history. 7. The Google Sycamore breakthrough. In 2019, Google shocked the world. Their 53-qubit Sycamore processor solved a random sampling problem in 200 seconds. They claimed it would take the best supercomputer 10,000 years. This was branded quantum supremacy. But IBM challenged the claim, saying classical optimizations could solve it in just 2.5 days. Still, the point was clear. For the first time, a quantum computer had entered territory no classical machine had touched before. 8. Quantum in finance and AMP. Economy, money never sleeps. Every second, billions of dollars move across the globe, stock markets, investments, loans, and trades. Classical computers can analyze data, but they hit walls when faced with trillions of variables. Quantum computing offers something new: optimization at an unimaginable scale. Banks like JP Morgan Chase and Goldman Sachs are testing quantum algorithms to design better, reduce risk, and even detect fraud patterns that classical AI misses. Imagine a quantum system balancing millions of trades, taxes, and risks in real time. That's not just profit, that's global stability. And if finance can benefit, think about industries where moving things from point A to point B decides everything. 9. Quantum in logistics and AMP. Supply chains, your phone, your clothes, even the food you eat, all depend on global supply chains. But disruptions, like the pandemic, showed us how fragile these systems are. Quantum computers could calculate the most efficient shipping routes for thousands of reduce fuel waste, and adapt instantly when ports close or demand spikes. Volkswagen tested this with optimizing routes for over 10,000 vehicles. The result? Less traffic, lower emissions, faster travel. This is the quiet kind of revolution. It won't look flashy, but it will change daily life. But beyond industry, there's a bigger race, one between nations. 10. The global quantum arms race. Make no mistake, quantum computing isn't just about business. It's geopolitics. China's MISQ satellite proved long-distance quantum communication, a step toward unhackable internet. The US, through DARPA and NISQ, is funding quantum defense and cryptography. Europe has its own quantum flagship project. India launched its national quantum mission in 2023 with a 6,000 crore budget. Why the rush? Because whoever leads in quantum could dominate cybersecurity, AI, and communications in the 21st century. It's like the nuclear race of the 20th century, but this time, the weapon is information. Speaking of weapons, let's talk about quantum's role in artificial intelligence. 11. Quantum plus artificial intelligence. Artificial intelligence learns by crunching massive datasets, but even the best GPUs struggle. Quantum computing could accelerate AI by exploring multiple solutions simultaneously. Imagine AI models trained in days, not months. Startups are already testing quantum machine learning, where qubits handle pattern recognition in ways classical math can't. This doesn't mean quantum AI will suddenly become conscious or read your mind. But it does mean breakthroughs in medicine, language processing, even climate modeling could arrive faster than anyone predicts. And speaking of climate, there's one battlefield where quantum might literally help save the planet. 12 Quantum for climate and AMP. Energy. Our world faces an energy crisis. We need cleaner fuels, better batteries, and smarter grids. Quantum computers could simulate chemical reactions to design new catalysts for carbon capture, or discover room temperature superconductors that make power grids ultra-efficient. Imagine electric cars charging in minutes, or solar energy stored without loss. Researchers are already using quantum simulations to study nitrogen fixation, the process that sustains agriculture, aiming to reduce greenhouse gas emissions. Quantum isn't just about profit or power. It could be a tool for survival. And survival takes us beyond Earth, into the final frontier. 23 Quantum in space exploration. Space is the ultimate unknown, and quantum tools may help us unlock it. NASA is exploring quantum algorithms to simulate rocket fuel reactions and spacecraft materials. Quantum sensors could detect gravitational waves or map underground water on Mars. And satellites with entangled photons may one day form the backbone of an interplanetary quantum internet, connecting Earth to Moon, Mars, and beyond. In short, the same technology that helps you order faster groceries today could one day guide humanity to the stars. But before we dream too far into the future, let's talk about the ethical, societal, and human side of this revolution. 13 Ethical dilemmas of quantum power. Every powerful technology carries risks. Quantum computers could crack today's encryption, threatening privacy, banking, even national security. They could supercharge surveillance systems, giving governments unprecedented control. But here's the paradox: the same quantum tech could also protect privacy with unhackable communication. So, is quantum a tool of freedom or control? That depends not on the science, but on how we, as societies, choose to use it. And speaking of societies, quantum's rise will deeply impact the workforce. 14 Jobs, economy and AMP. The quantum workforce. Quantum won't just change machines. It will change people's jobs. Some fields, like cybersecurity and classical encryption, may face disruption. But new roles will emerge: quantum software engineers, error correction experts, quantum algorithm designers. Governments and universities are already preparing. The EU's quantum flagship funds education programs. India's national quantum mission includes skill building for engineers. A new generation of workers will be needed to bridge physics, computer science, and mathematics. For students today, quantum may be the career opportunity of tomorrow. But when, exactly, will this future arrive? Let's talk timelines. 15 Timeline. What's near versus far? Here's the hard truth. Fully error-corrected, universal quantum computers are still decades away. We're talking late 2030s, maybe even 2040s. But don't be fooled, useful quantum applications are already emerging today in optimization, chemistry, and logistics. The near-term decade will see quantum as a partner to classical supercomputers, solving niche problems together. The long term? True breakthroughs in AI, energy, and materials, things that could reshape civilization itself. But before we end, let's bust some myths once and for all. 16 Quantum myths versus truths. Let's clear the air. Myth: quantum computers will replace classical ones. Truth: they'll complement them, just like GPUs work with CPUs today. Myth: quantum computers will instantly crack all passwords tomorrow. Truth: we're still decades away, and post-quantum encryption is already being built. Myth: quantum computers mean instant artificial general intelligence. Truth: Quantum helps AI, but it doesn't magically make machines self-aware. Reality is stranger and harder than fiction, but also far more exciting. So, after all this, what does it mean for us? 17. A quantum future. Hope and AMP. Responsibility. Quantum computing is more than a scientific breakthrough. It's a mirror, showing us both our ambition and our responsibility. This technology could heal the sick, protect the planet, and explore the stars, or it could deepen divides and create new risks. The choice isn't up to qubits. It's up to us, scientists, governments, and everyday people, to guide this revolution with wisdom. So here we stand, at the dawn of the quantum age. From medicine to Mars, from finance to freedom, quantum computing could reshape everything we know about technology and about ourselves. But the real question is, are we ready for it? And now, I'll leave it to you. If you had access to the first truly powerful quantum computer, what problem would you want it to solve first?